Hey there everybody. So in this video what we're going to talk about are the similar triangle theorems. There are 3 of them. We're used to 5 theorems, the big 5 if you remember: side, 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 angle, 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 side, and HL. Well, this is going to be similar, except there's only going to be 3 of them, and instead of saying that triangles are exactly the same, we are going to say our triangles are similar. And similar, remember, means the sides aren't the same, they're in proportion. Angles are the same, but sides are in proportion. So the 3 similarity theorems we're going to look at are angle, angle, we call it AA, side, 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 SSS, and side, angle, side, SAS. AA means that 2 angles of one triangle are going to be congruent to 2 angles of another triangle. So if we have 2 angles that are congruent, we know the triangles are similar. So what we notice here, when we're looking at this one, what I see is angle A is congruent to angle D, and I know angle C is congruent to angle E. Now, if 2 angles of a triangle are congruent to 2 angles of another triangle, what we know automatically, that should have been a different color. That should have been green. What we know automatically is that the third angles are also congruent. If 2 angles of 2 triangles are congruent, the third angles have to be, because remember, angles of a triangle always add up to 180. So what we know here is we know triangle ABC is similar to triangle. Now let's look at the order we went in. It's important, remember, that our order lines up. We did yellow first, so yellow needs to come first over here. And then we did green, because that's B, and so that means green has to be second over here. And then lastly we did blue, so blue has to be third there. All right, so when we fill this in, we have triangle ABC, yellow, green, blue, and that's going to be yellow, green, blue, which is D, E, F. Remember, just because it's alphabetical in some examples doesn't mean it will always be alphabetical. And why are these 2 triangles congruent? They're congruent because of angle, angle. Now let's take another. Ooh, now this one doesn't look like angle, angle. Because what we have when we look at this one, we're like, all right, let's look. I've got V congruent to Y. Angle V is congruent to angle Y. And no other angles are marked. Except, remember, way back to first semester, these angles are also congruent because they are vertical angles. And vertical angles are always congruent to each other. Vertical angles on opposite sides of the X like that. And they are always congruent to each other. And if 2 angles are congruent, the third angles must be. So I am going to write down the first triangle name, triangle. I like to put the first one in alphabetical order because why not? VWX. And VWX is in the order of yellow, so I need a yellow, blue. Oops, I did it again. Blue and green. So when I write my second triangle, my similarity statement, I'm going to say similar to triangle, and I'm going to need to go yellow, blue, green as well. The green didn't take. There it is. And so that'll be Y, Z, X. How are they? Why are they similar? They are similar by angle, angle. And remember, if the 2 triangles are similar, all 3 angles are going to be the same, and my sides are going to be in proportion. All right, our second similarity theorem says side, side, side. So if 3 sides of one triangle are in proportion to 3 sides of another triangle, then the 2 triangles themselves are similar. What that means is I am going to do long side over long side, and that needs to equal the middle side over the middle side, and that will equal short side over short side. So when I write this out, on the triangle on the left, I always like to go left to right. I'm going to start by finding the longest side, 5. And then my longest side on the right is 10. So I'm going to try to put the long over the long, because we start with long and long. And then I'm going to go middle to middle. Well, on the left side, the middle side is 4. and on the right triangle it's 8. And then short side and short side. So when I write all of these in, these three fractions need to be equal to each other, and they all need to reduce to the same number. And remember, that number is going to be called my similarity ratio. So when I work left to right, I'm going to go 5 over 10, 4 over 8, and 3 over 6. And all of these all those fractions reduce to 1/2. 1/2 is my similarity ratio from the triangle on the left to the triangle on the right. So I know triangle PQR is similar to triangle. It's important that the second one match the order. So I did PQR. PQR. Well, P is between green and blue. P is between green and blue. So what angle over here, what letter touches green and blue? That's going to be S. Q touches blue and yellow. That's going to be T. And R touches green and yellow, which is U. And then why are they similar? They are similar by side, side, side. So you're going to tell me the two triangles are similar, and then you're going to tell me why they are similar when we do our work. Let's do another one. Now remember, we're going to do long over long, middle over middle, short over short, and all of those need to reduce to the same fraction. And if they do not reduce to the same fraction, then the triangles are not similar. These ones, instead of going left to right, they're top to bottom, but the idea is still the same. So I'm going to start with the long side and the long side. So 14 and 56. So when I write that fraction, we're going to do long over long. And then I'm going to do the middle side over the middle side. So that's 11 and 44. Boom, boom. And then the last two. Because this only works with triangles, these theorems, because of the three sides. So we're going to make these three fractions equal to each other. If they are equal to each other, these triangles are similar. So we're going to get 14 over 56, 11 over 44, and 10 over 40. So when I reduce these, 14 goes into 56 4 times, so this becomes 1/4. 11 over 44 is 1/4. 10 over 40 is also 1/4. All of them reduced to the same fraction. That means a 1/4 is my similarity ratio, and it means these two triangles are similar. Triangle ABC is going to be similar to triangle. So ABC, A is at yellow and green. So yellow and green is going to be L. B is green and blue, K. And then C is blue and yellow, and that will be J. And they are similar by the side, side, side theorem. Or postulate. That's a theorem. Angle, angle is the postulate. And our last one is side, angle, side. Two sides, angle in the middle. Two sides, angle in the middle. If two sides of one triangle are in proportion with two sides of another triangle and the included angle, that means angle in the middle, then the triangles are similar. So we're looking for two sides to be in proportion, just two, and the angle in the middle has to be congruent. So to do side, angle, side, I'm going to say hey, check it out. I've already got the angle, and we have long side, and we've got the short sides. Boom, boom. The question is, are the fractions the same? That's what we have to check. I got the angle between the two highlighted sides. That's always a good start for side, angle, side. Now let's see, are my fractions the same? So I'm going to do yellow over yellow, 20 over 15. I am working left to right, so the next fraction also has to be left to right. And then I see what both of these reduce to. I can divide 20 over 15, divide them both by 5. That gives me 4/3. Divide both of these by 2, 4/3. Hey, the sides are in proportion. So, and that is my similarity ratio, 4/3. So I know triangle JKL is similar to triangle RE. So J is at the end of blue and blank. So that's going to be M. Went up to K, went up the 8 to the green angle. So that's going to be N. You know what? Let me do this. Triangle MNP. And why are they similar? Because of the side angle side theorem. And then your next example, let's just take a look, because sometimes we're going to get triangles that look like this, and they're a little wacky, but that is okay. What we have is we have two different triangles inside of each other. So notice right here, both of those share E. And then my sides are going to be these lengths right here. Okay, so we did part and the whole thing. So I've got E is in both triangles. Now we're going to do long over long. And we're going to see, does that equal short over short? So my longest number, oh, dang it. Well, I don't know what this long blue side is. Oh, but 25 plus 30, that's 55. 25 plus 30 is 55. And this one is 42. How did I get 42? 77 minus 35. I just realized that it looks like I'm leaning way into the camera. I'm not. I'm trying to touch my touch screen to write on it. So don't get freaked out. I can't see you. So when I write this, we're going to write 77 over 55. And we're going to ask ourselves, does that equal 42 over 30? Please pay attention that I went the same way every time, top over bottom. So this becomes 7 over 5. And then I can divide both of those by 6, and that is also 7 over 5. Yes, they're the same fraction. That means those sides are in proportion. So I know triangle, and really don't care which one you start with. I am going to go AEB. I'm going to do the little one on the inside is similar to triangle AEB. So that's going to be GEF. Why are they similar? They're similar because of side angle side. Hey, I know this was a little longer video, Patriots, and I appreciate you hanging in there till the end. It's very important that you write all these theorems down and that you come in ready to work. I can't tell you how much I appreciate it that you stuck around till the end. And remember, if you like this video, please give it that big old thumbs up. Let me know that you appreciated it. And if you have any comments when you see me, just let me know when you see me at school. I'm in R16, whatever I can do to make it better, let me know, because feedback is the breakfast of champions. So Patriots, we will see you when we see you, and come to class with any questions that you might have.